Hello tube users, it's DrRunCMD yet again with another video for you. So today we're going to be looking at quite a nice little piece of equipment. This is a power supply for keypad controlled security doors and or fire doors, and the idea behind it is it provides a supply to keypad entry doors, and in the event of a fire, so the fire alarm is triggered, then power is cut to those keypad enabled doors, so you can use them as fire doors. So I suppose might be quite interesting to have a look at. These are backed up by a 12 volt battery included in the system, so I suppose once the power is cut, 12 volts is still supplied to the unit, which allows the keypads to be disabled for that time. And once obviously the fire alarm is reset, the power is put back into the system and the keypads are activated again. So quite an interesting unit, so I thought we'd have a look. This is the 12 volt linear power supply 4. It's rated 2 amps continuous and peak 5 amps. So you're looking at, it's 12 volts, so it's what, 24 watts continuous, and 5 amps, which is about what, 50 watts peak current or peak power draw. So we'll have a look at the transformer in a moment. So we'll just focus on this little device here. So what I'm going to do with this, so it's focusing on the metal shield, what I'm going to do with this in a moment is going to take this off. I'm not sure why there is a large heatsink. There's no MOSFETs or transistors or any power devices attached to, so that's quite strange. So let me dismantle these bits and pieces and we'll have a look closely at the circuit board. There are some outputs as well and inputs like signal controls and all that stuff, and strangely enough a 555 timer chip sitting down there, obviously a relay, and obviously some power transistors or passive transistors for generating the power supply. So as you can see there, the 2 transistors there. So let's have a look, shall we? So let's take this part off. Obviously there's just some screws. Well, so I don't know why they've got a massive great stonking heatsink on this thing. It's not like it generates heat, or there's no sort of, as I said, power devices attached to. It's literally, the circuit board is just with a couple of headers just attached to the metal chassis. So there's no purpose really for this heatsink other than the fact that it reaches to the out of the case, so it has the LEDs in to show you what's going on. That's the manufacturer if anyone's interested. So could be used for another project. Quite a good little heatsink. And as I say, you've got this metal plate now, which I will also take off, so then we can have a bit of a closer look at the circuit board. I like the diodes there, just to where my screwdriver is. Nice and beefy. For the bridge rectifier, obviously discrete. And discrete meaning obviously it's just made up of some diodes. Let me unplug the LED. These wires are a bit, I think that's a bit jiffy. They've just literally soldered those 2 wires on, and I say they're for the 12 volt battery backup or background supply, I suppose. And here, as I say, you can see there's actually some text on those. So not connected, common, 12 volts, ground, push, and control. Interesting. Let's have a look. There's the 555 timer. Sorry, you can't read the text. I think there was some sort of sticker or something on it. There's a nice little relay there, a 5 watt resistor for the power supply. Let's have a look at the chippies, shall we? I need to move my light so you can see the chip markings, but I don't suppose you want to have a look at those. I'll find out, I'll leave them in the description if you want to know what they are. But generally on first look it looks like a linear power supply. I'll grab a power supply, 12 volt linear power supply, and I'll show you the similarities in sort of components. So let me grab that and we'll have a look at that. And this is a linear power supply I bought from eBay, I think. Obviously, as you can see, 2 transistors there. Match those 2 transistors there, especially the package. There you go, you've got the big power resistor there. Nice and juicy cap. Obviously inputs and outputs, a lot of resistors. A couple of small diodes, none of those big ones. 3 op amps on there for the control. But yeah, I think there are definitely some similarities too. So it does show it is a linear power supply. So let's next have a look at the transformer in question. And I say this was making a very loud buzzing noise when it was powered in the unit that it was in. So I'm not sure if that's dead or not. So we'll have a look next into giving this baby 240 volts and see what happens. And yes, it is fused. There's a nice little plug fuse there, which we can use and made for our safety. So if it does decide to short or blow, it'll blow the fuse before blowing us up. So let's have a look. And for some reason that's quite bent on the bottom. Like I say, it's not in a position where it was moved around a lot. It's a stationary box in a cupboard, although it does get quite warm in that cupboard, so maybe it's failed due to overheat for a long period of time, who knows. So let's have a look and see if we can get this one powered up. I'll test this on its own first and see if we get 12 volts coming out the back end. And being a linear power supply, we're probably going to see about 13-14 volts that come out, because obviously it's going to be unloaded. So when you power these transformers up, you'll get a slightly higher voltage reading than what it states on the actual transformer itself. So this says 12 and unloaded with nothing on the end, nothing drawing any power from it. We'll probably get about 13-14 volts. So let's have a look. Well, I've grabbed my power cord. We're not going to earth this unit because there's nothing metal we're going to be touching, so no need to worry about that, but it's a good idea to keep that earth out of the way for this test anyway, specifically. So let's hook this up. Doesn't matter if you use what connection you use. Obviously being AC current, it's not polarity. Polarity is not required. I should open that a little bit more. Obviously AC, obviously, as you know, is different from DC. DC is a fixed current, a fixed voltage, either on or off. AC is like a sinusoidal kind of waveform, and it varies. I'll go into more detail at some other point, or if you already know, then I'll be quiet. But as I say, excuse me, as I say, it is fused for our protection, so that's good. Hopefully it should, we never know, it might go bang. And we'll show you how a fuse works. So let's first, oh, did you see that? That's the point of failure right there. Oh man, I was hoping to plug this in and see what happened. That's not good. That's not good at all. Let me check this one. Well, that one's quite nicely snugged on there. But look, you can see the break in the cable. That is quite bad. That is quite bad. As I say, this was, I did have excessive heat in a room, in a sort of enclosed room with no airflow for quite some time. So I think we've found the root cause of the problem. That might have something to do with the buzzing as well. You've got a loose connection. There's a couple of strands on the wire connected, but the others aren't. You're going to get sparking across. So, oh man, I'll have to go and find another linear power supply now, or I might just chuck that out the way. And what we shall do, actually what I will do, might be easier, I'll generate 12 volts from my power supply and I'll attach via the battery contacts, because it's only 12 volt supply going in. I'll current limit it, the supply anyway, and we'll see what happens. What a pain in the backside. Well, welcome back. My camera decided to run out of battery. One thing about filming videos or doing YouTube videos is make sure you've charged your camera battery up, which clearly I didn't do. But anyway, a little bit further testing. That was getting very hot very quickly. I don't know if that's normal operation. I don't suppose it is. All it's really doing is not much at all. Feeding 12 volts from the battery connections. There's no voltage or amperage conversion going on. So really, those transistors there, which provide the voltage and whatnot from the rectified DC coming in from the power pack, are not actually being used, because I'm feeding it like 12 volts directly in essence. So not sure what to do with that one. No activity on the light. I said I got very warm very quickly, so I didn't want to leave it on for any particular reason. So I'm afraid that's about the most I can do with this security keypad power supply door system stroke, whatever you want to call it. I had no 12 volts on the output. The control was showing what, half a volt, and the signals were showing half a volt as well. So obviously, not having the rest of the connections there, there's not much really I can do. So that's it from me from today. I'm also going to throw that transformer away. And I say I may have some uses for this big fat heatsink, which I might use for my DC load project that I've built over the corner there, which you can't really see. So yeah, sorry that was a bit anticlimactic, but that's all we can do for now. So stay tuned, please subscribe and comment, and link down below. See you YouTubers later.